Hello everyone, and welcome to the 7th and last tutorial video for the BiOS app. My name is Stu Spencer and I'm a senior researcher at FP Innovations. In this video series, we are working through a mock-up scenario with the BiOS app, providing step-by-step direction to assist potential users. If you have not yet watched the first 6 videos, I would highly recommend you go and do that first. In this video, we're going to begin with the media page. The media page allows you to take and store pictures while in the cutblock or add maps from outside sources. To take a picture, simply tap the camera icon on the upper right side of the page. To import a map or other file, tap the landscape icon to the left of the camera icon and choose your file. You will be prompted to add a description and then add the picture to the main media page. You can also delete files you no longer have use for, or update the description by tapping on the picture and then following the prompts. Tap Complete when you are finished with the media page, and the app will then generate the BiOS report. The BiOS app report is broken into 5 sections. I will go through each one of them and then give a short demonstration of the edit and export functions. The first section in the report is the biomass recovery section. This section summarizes the block area in hectares, the total recoverable biomass for the cut block in oven-dried tons, the average moisture content of the feedstock, the biomass yield in oven-dried tons per hectare, the amount of biomass in oven-dried tons per cubic meter of merchantable volume, the low heating value, fuel consumption for the recovery phase in liters per oven-dried tons, and the greenhouse gas emissions for the recovery phase in CO2 equivalent tons. The second section of the report is the biomass transport section. This section will summarize the total distance to the end user and for each of the road types in kilometers. It also summarizes the fuel consumed to deliver the feedstock to the user and the greenhouse gas emissions for delivery measured in greenhouse gas equivalent tons. The third section, called Biomass Supply Cost, summarizes the costs associated to the recovery and transport of the feedstock to the end user. The fourth section, called Species Breakdown, summarizes the recoverable weight in total oven-dried tons for the cut block, in oven-dried tons per cubic meter, and oven-dried tons per hectare. It also summarizes the amount of delivered carbon and the amount of greenhouse gas produced if the residue was to be burned at roadside. Lastly, this section provides a carbon ratio which compares the volume of greenhouse gas delivered versus the amount of greenhouse gas created to harvest and transport the feedstock. The last section produced in the report is the biomass flow diagram. I will go through the boxes in the flow diagram and explain what each of them means. At the top center of the flow diagram is the total fiber box. This represents all of the fiber in the cut block, including merchantable volume and non-merchantable fiber. Non-merchantable fiber includes all of the branches, needles, bark, and pieces that are too small to meet merchantable specifications. The box on the farthest left of the page displays the projected merchantable fiber that will be harvested during the primary harvest. This number is deducted from the total fiber volume, and you are left with available biomass, natural losses, and uncut trees. Natural losses include the needles and leaves that fall off between the primary and secondary harvest. If the secondary harvest occurs shortly after the primary harvest, this value will be 0. The uncut trees box displays the amount of volume left standing. If you enter 100% for harvest removal in the species page, this value will be 0. Of the available biomass, a certain amount of the volume will be left in the dispersed area of the cut block. The cutover residues usually includes all of the small pieces that are too small or too awkward to collect and haul to roadside. When the cutover residues are deducted from the available biomass, you are left with the value in the roadside box located near the bottom of the diagram. Of the volume that makes it to roadside, a small amount will not be harvested. This value is influenced by the recovery technical efficiency value in the edit page for biomass recovery. When the not recovered volume is deducted from the roadside volume, you are left with the recovered biomass value. This is the amount of biomass the operator can expect to harvest. Beside the roadside box is the summary of piles entered on the visual estimator page. If you did not enter any piles, this number will be 0. To the left of the recovered biomass is the recovered/available box. This value is a percentage based on the recovered biomass divided by the available biomass plus natural losses. To the right of the recovered biomass is the biomass ratio. This is a percentage which represents the recovered biomass divided by the merchantable volume harvested. These values can be useful for comparing different cut blocks. Below the biomass flow diagram, a map of your cut block with roads, boundary, and pile footprints is also produced. So that finishes the summary of the reports. I will now go through how to edit the project and export the report. To edit the report, simply tap the little blue pencil icon on the top left of the screen. After you tap, you will be taken to a page that displays icons for all of the data entry pages. By tapping on the icons, you will be able to re-enter data, and if you make changes to these pages, the report will be regenerated. A couple of important edits to note are how to change the moisture content of your feedstock, and as mentioned in video 4, I'll show you where you can change the pre-piler values. If you wish to change the moisture content for your species, you will need to go back to the species page. Tap the species you wish to make changes for, in this case Douglas fir. Change the moisture content from the default value of 45 to whatever you wish. You will also notice that you can now change the dry and green density for your species, although this is not recommended if you are not familiar with the concepts. After changing the moisture content or any other field, tap Update and then Save. To edit the pre-piler function, click the biomass icon, and you will see the Edit button for the pre-piler on the left side of the page. Click the Edit button, and as you can see, the edit features for the pre-piler are the same as those for the other biomass harvest machines. When you finish making changes, tap Save in the bottom right of the page. I should also mention the value in the upper left of the page called Technical Losses at the Stump. Changing this value will affect the amount of cutover residues that are deducted from available biomass on the biomass flow diagram. When you are finished editing, press Save in the bottom right corner of the page. If you are completely finished editing the project, tap Report in the bottom right corner, and the report will be regenerated. The last thing I'll do in this video series is show you how to export the report. Tap the green and white arrow icon on the top right of the page above the report. After you tap the button, you will be given a wide range of options for exporting. The exported file will include all of the report in one PDF document. So that will end video 7 and our tutorial series. I hope these videos have been useful and you now feel better equipped to go out and calculate roadside biomass. If you have any questions about the app, please feel free to contact me, Stu Spencer, at stuart.spencer@fpinnovations.ca.